colloidal solution, and there were actually two different methods, right? The two methods were, the first one, what we call it as a chemical method, and the second one was a dispersion method. Chemical method में types थे वो हमने कल देख ही लिया था. That was the first one was, yes, the first one in the chemical method was the oxidation method, wherein one of the particular reactant gets oxidized and comes into the dispersion medium. Sulfur का जो example था, hydrogen sulfide का जो example था, वो हमने देख लिया था, right? So it is going to react with what the sulfur dioxide, and then water is formed along with sulfur particles. Correct. This is what example we had seen yesterday at the end. So after this was a reduction method, wherein one of the reactant usually gets reduced, and then it comes as a particle in the dispersion medium. The example what we had seen was of ferric chloride, sorry, AuCl3, gold chloride, and stannous chloride. Okay, so the next one was a double decomposition method, wherein we had seen about arsenic sulfide, and finally was the hydrolysis method. So these are the four methods what we had seen under the chemical method for the preparation of colloid. So today we will start up with the next and most important one. Now for exams, you can just expect that these particular questions are not going to be asked. Okay, but when we come to the dispersion method, this is the most important one, and I will tell you where you need to actually concentrate on. Okay, so in dispersion method, the most important first one is the Bradig's arc method. Remember this, it's most important and the much more easier one to remember and to get 3 marks directly. Okay, so in Bradig's arc method, what will be there is it's going to be an apparatus containing two beakers. Okay, something like this. Now if you observe it carefully, you will see that there are actually two beakers there. Where are the two beakers? If you see, this is your first beaker. Okay, and this is actually the second beaker. Okay, so the second larger beaker, what you see, there is ice bath. They have written it as an ice bath. Ice bath in a sense that here, entire thing, they are keeping ice. So when we keep an ice, naturally what will happen is this particular section will start getting cooled, right? So, and here in this particular case, they will keep a particular solvent. Okay, solvent in a sense, something like water. Okay, and after that, here, whichever the sole that you are trying to prepare, a colloidal sole, what you are trying to prepare, that particular sole is prepared by using these metal rods. Agar, for example, if I want to prepare a gold sole, G-O-L-D, gold sole, then what will happen? I'm going to take this particular rods, what you see, made up of gold. Okay, so once that particular thing is taken, that this particular rods, what you see, are taken of the material or a metal from which you want to prepare a sole. If I want to prepare a silver sole, then I will see that this particular thing is made up of silver rods. Okay, these electrodes are made up of silver rods. So depending upon what kind of colloid that you want to prepare, that particular metal we are going to select. Quite simple as that. Now, after selecting those metal electrodes, what shall we do is we will take that particular metal electrodes and we are going to connect this particular metal electrode to the battery. Okay, positive and negative terminals of the battery is going to be connected. And it is going to see that the voltage is very, very high. So therefore, when you supply high voltage, क्या हो जाएगा? High voltage supply करेंगे तो क्या हो जाएगा? High temperature हो जाएगा. Okay, it is going to give a high temperature. That means at this particular region, there is a high temperature which is formed. Due to high temperature, the entire electrode will start getting dispersed. Dispersed यानी कि क्या हो जाएगा? It will start getting broken down into the smaller fragments because of the high temperature. Okay, it will break down itself at its atomic size, but there is a cooling system over here, what we have already seen, correct? So this thing is cooling that particular beaker. So as it is cooling that particular beaker, what will happen is the particles what are getting released, okay, the particles which are getting released over here, due to this cool system or cold system here, all these particular particles will aggregate in order to form a particle which is there in the colloidal range. यानी कि यहाँ पर because of the cooling system, because of the cooling effect, you can see that there is going to be the particles aggregation. Aggregation यानी कि क्या हो जाएगा? सब particles आके एक तरफ रुक जाएंगे. Okay, they will start getting like a clump like formation they will show. Now, this particular colloid is not stable for a long time. And in order to make it stable, what we do is usually we use a particular thing, what we call it as a stabilizer. Okay, so quite easy in examination. You can expect this particular thing for a 3-mark subdivision. Direct question it will be there. What is a Bradig's arc method? Okay, so Bradig's arc method, it is a method of the preparation of colloid wherein what we do is we are going to see that the two rods of suitable metal are dipped into the water or a solvent which is actually placed in an ice bath. When electric discharge is carried out, that means when you are going to supply the electricity, the metal whatever we have here, this particular metal will start getting vaporized. It will start getting broken down due to the intense heat what is going to be produced due to the high voltage. Okay, now after that what will happen? All the particles will start coming into the water. Okay, but due to the cold water, these particles will try to come close to each other and then they form the particles which are there in the colloidal range. Okay, so some of the stabilizing agents are also required here in order to see that this entire colloid is going to be quite stable. Okay, what kind of soles that we usually prepare? We prepare here the soles of gold, okay, silver, platinum. Such kind of soles are usually prepared by this particular method. Okay, so I hope you understood this. Quite simple. If you just draw this diagram, you can expect 1 mark over there only, and explanation another 2 marks. Okay, so quite easy it is. You can just observe. Done. So shall we start with the next? So I hope there is no problem. I hope you have you have understood the entire concept of the Bradig's arc method. Okay, so shall we start with the next one? The next particular thing is called as a peptization. Peptization is the most easiest one that you can ever get. Okay, so in peptization, what will happen now is, let us say for a moment that we have a beaker, and in this beaker, what will happen is, let's say that we have a particular solvent. Okay, solvent है हमारे पास. Solvent यानी कि पानी है. Okay, so in this case, what shall we do is we are going to add some amount of, let us say, a particular reactant. Reactant A डालेंगे और यहाँ से reactant B डालेंगे. Okay, so once the reaction completes, let's say once the reaction completes, what will happen is the reaction gives precipitate. So naturally what I'm getting here is all this precipitate. All right, so there is a precipitate formation. Precipitate यानी कि सब कुछ जो settle down हो गया reaction के बाद. Okay, so now what I will do is, just a minute please, there is a problem. Okay, so once the precipitate is formed, then what will happen is, okay, once a precipitate is formed, so what we'll do is, for this particular precipitate, we are going to add small amount of, observe what we are going to add. We are going to add small amount of electrolyte. Okay, now when we add a small amount of electrolyte to that, so what will happen is, let us say that this is one particle, let us say this is only one particle of precipitate. अगर ये precipitate है, ओके, ये एक ही प्रेसिपिटेट है जो कहां से मिल चुका है मुझे, ओके, जो मुझे यहाँ से precipitate. Let's say only one precipitate molecule we are taking into our study right now. Okay, so now what will happen is once you add the electrolyte यानी कि क्या हो जाएगा, electrolyte यानी कि जो particular substances such as NaCl, okay, या फिर KCl. Okay, so when you add it in water, what is going to happen? That particular thing is going to get broken down as Na plus and Cl minus, correct? So now what will happen is one out of these will try, one out of these plus or minus will try and settle down on the surface of this precipitate. Okay, so अगर precipitate के ऊपर अगर वो settle होने लगा तो कुछ क्या हो जाएगा, कुछ इस तरह से दिखेगा ना, यहाँ पर ना एक पर्टिकुलर चार्ज दिखेगा आपको. ओके, ओनली वन पर्टिकुलर चार्ज इज गोइंग टू गेट सेटल्ड ऑन द सरफेस, समथिंग लाइक दिस. ओके, इट कैन बी ओनली पॉजिटिव चार्ज और ओनली इट कैन बी नेगेटिव चार्ज. यानी कि ओके, दैट मीन्स what I'm going to see is all these particles what we have are going to be surrounded by a particular charge. पॉजिटिव रहा तो सब कुछ पॉजिटिव में रहेगा. So positive, 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 what will happen? Because of like charges, everyone will start getting floated over here, something like this. Okay, so all these particles will start floating because of the charge what is present on the surface of the particle here. Okay, particle यहाँ था और इस पार्टिकल के ऊपर हमने क्या लगा दिया, यहाँ पर चार्जेस आ गए हैं यहाँ पर because of the electrolytes. Okay, so these electrolytes will start to come and they will surround this entire surface by this particular charge, right? So as a result, all this precipitate what we have here, this precipitate will be having only one particular charge on them. And this particular one charge, because of the like charges, the particles will start floating on the top rather than settling. So therefore, this entire solution what we have right now, this solution will start acting as your colloidal solution. Okay, it will start acting as a colloidal solution. So you can expect only an definition for this. So let us see what can be the definition. Okay, so the definition is when a freshly prepared precipitate can be dispersed into the colloidal solution by shaking it with a small amount of electrolytes. This particular method, we call it as peptization. Okay, यहाँ पर देखो क्या मैंने मेंशन कर दिया है, यहाँ पर न्यूट्रल FeOH3 यानी कि फेरस हाइड्रोक्साइड पार्टिकल्स जो हैं यहाँ पे, फेरिक हाइड्रोक्साइड पार्टिकल्स जो हैं यहाँ पे प्रेसिपिटेट हो चुके हैं. So for this, we are going to add small amount of electrolyte, that is FeCl3. Because of addition of FeCl3, positive charge are coming and they are settling on the surface of these particles. Okay, due to which all the particles will start acting as a positively charged. Because of the like charges, they are not going to settle down, rather they are going to go back into the dispersion medium, and therefore the entire system now will be acting as your colloidal solution. Quite simple as that. Okay, there is nothing more, and you can expect this for your 2 marks. Okay, so remember, you can expect this particular thing for your 2 mark subdivision. Okay, most important. So Bredig-Zark method 3 marks, peptization method 2 marks. All right, let's go with the next. Purification. अब purification of salts यानी कि क्या हो जाएगा, हमने preparation of salts देख लिया था. Preparation of salts, in most of the time what is happening, in most of the time that you are seeing that whenever you have a particular beaker containing a solution where you want to convert that particular thing into, a sol, what is happening there? When you want to convert that thing into sol, you are adding something, and that addition of something is nothing more than an electrolyte, correct? अगर मैंने इस particular system में ज़्यादा electrolyte डाल दिया, if I'm going to add extra electrolyte, okay, if we are going to add extra electrolyte, then what is required, then what will happen is this extra electrolyte will see that whatever the particles are there of the colloid inside this, that particular thing is going to be, okay, that is going to be again क्या हो रहा है यहाँ पर, एक्स्ट्रा इलेक्ट्रोलाइट अगर मैंने डाल दिया तो प्रेसिपिटेट हो रहा है। ऐसा क्यों? बिकॉज वॉट एवर यू हैव सीन, वॉट एवर the what you can say as whatever the particles that you had seen, just a minute please, yeah, whatever the particles that you had seen over here, which was of the colloid, this particular thing was containing, as already that you had seen, that this particular thing was containing on the surface of it different type of, on the surface of this, you had already seen that it was containing a different type of charges. The charges which were there were actually because of the electrolytes, right? The electrolytes what you had used. What kind of electrolytes that you had used was NaCl or KCl or something like this, due to which this particular particles, okay, due to which this particular particles had a charge on them. Okay, it can be a positive charge or negative charge. जब हम एक्स्ट्रा इलेक्ट्रोलाइट को डाल देंगे, तब क्या हो जाएगा, इस पर्टिकुलर चार्जेस के ऊपर और एक अपोजिट चार्ज आ जाएगा यहाँ पे. So what will happen if the first sphere is acting, okay, I'm sorry for some inconvenience. I don't know why this application is malfunctioning today. Okay, please let's see like how far we can go with this. Okay, so what will happen is if you add extra electrolyte, what was happening was there, the entire charge which was there on the particle, okay, the entire charge which was there on the particle, the small ones, this particular charges were getting attracted by the opposite charges. Opposite charges कहाँ से आ रहे थे, हम जब हम एक extra electrolyte को add up करेंगे. Okay, so if the first circle, red circles are of your positive charges, let's say the black circles are of negative charges, due to which what is going to happen is the entire system what you see is going to be neutralized. अगर ये neutralize हो गया तो वापस ये क्या हो जाएगा, ये गिर जाएगा वापस as a precipitate solution में वापस गिर जाएगा. Okay, it will start getting broken down or it will start getting precipitate. So the process, remember this, so the process of removing the traces, the extra traces, I would say as extra traces of the electrolytes is known as, that particular thing is known as your purification of salts. Then there are various of methods for this. Okay, so let us see what are the different methods. So the first one is called as a simple diffusion method, and the second one, what we call it as the electrodialysis method. Okay, first one you can also call it as a dialysis method. जो simple diffusion method करके बोला है हमने, you can also say it as a simple dialysis process. Okay, so now what will happen in the simple dialysis process? First, I would like to show you the figure. Okay, so observe the figure carefully. So what is happening is, in this case, first, a colloidal solution containing extra amount of electrolyte is going to be taken in this particular bag. I hope you can see the bag over here. Okay, so that particular bag contains an extra electrolyte. Sorry, it contains the colloidal solution containing extra electrolyte. Okay, उसीलिए हमने क्या बोल दिया है, impure sol यानी कि colloidal particle. Now, what we are adding here is an extra electrolyte. अभी electrolyte क्या है, NaCl, KCl type of things, right? So when I add NaCl, okay, when we add NaCl, so once it breaks down, of course I know it is going to form as Na plus and it is going to form as Cl. What we know is it is going to act as a Cl minus, right? So now when we add this, the Na plus and Cl minus what we have, they are of very small size. ये क्या हो रहा है, उसका size जो है बहुत ही छोटा रहेगा when we compare to that of the colloidal particle. Remember, the size of these ions are actually smaller than the size of your colloidal particles. Okay, let us say that these are all your colloidal particles here. Okay, and ये जो red color के markings है, let us say for a moment that are your extra electrolytes. Okay, so now what is going to happen is they are going to see that this entire impure soul is going to be taken in this bag, and this bag is called as a parchment paper. Okay, or it is also called as cellophane paper. Okay, cellophane paper membrane. Now this particular thing is going to be dipped in a flowing water. पानी यहाँ से क्या हो रहेगा? It will be continuously flowing. Okay, so they are going to keep this particular thing in a flowing water. Now this parchment paper, what we see, has a unique feature. What feature it has is it has a small openings. Parchment paper या फिर cellophane membrane जो है उसमें छोटे से openings रहेंगे. इतने छोटे openings रहेंगे कि सिर्फ ions पास हो जाएंगे. Ions, I am speaking only about ions. Ions यानी कि क्या हो जाएगा? Na plus या फिर Cl minus उतने ही पास हो सकते हैं यहाँ से, क्योंकि उसके साइज जो है the Na plus and Cl minus sizes what we have are very very small when we compare to the size of our colloidal particles. Therefore, what is going to happen is all these particles will flow with the flowing water aside. Okay, so Na plus and Cl minus will go aside. But what will contain in the bag, what will remain in the bag is my colloidal particles only. Only they will stay there, the rest of them will just go away. Okay, अब यहाँ पर ions, जब हम ions करके बोल रहे हैं, ions के ऊपर क्या चार्जेस हैं? एक तो अगर पॉजिटिव है, पॉजिटिव चार्ज है या फिर नेगेटिव चार्ज है, राइट? ये याद रखो, क्योंकि इसको यूज करके, ये नेचर को यूज करके हम पढ़ेंगे द नेक्स्ट सेक्शन व्हाट वी कॉल इट एज द इलेक्ट्रोडायलाइसिस मेथड. सो सिंपल डायलाइसिस मेथड में क्या हो रहा है? इम्प्योर सोल पार्चमेंट पेपर में लेंगे, बाद में उस पर्टिकुलर पार्चमेंट पेपर को हम डिप करेंगे एक बीकर में जहां पर पानी कंटिन्यूसली फ्लो होता रहे. ओके, so once the water is continuously flowing, parchment paper will see that all the ions will be pushed aside. Extra ions whatever they have, they will be pushed aside, and that particular thing will be carried away with water. Okay, and only ions can go because the parchment paper has the pores which are very very small, which will only see that the negative particles can go aside, sorry, which will see that only the ions will go aside and the actual particles will remain as it is. Okay, so इलेक्ट्रोडायलाइसिस, अभी डायलाइसिस समझ लिए. इलेक्ट्रोडायलाइसिस, इलेक्ट्रो यानी कि क्या करेंगे हम? इलेक्ट्रिसिटी प्रोवाइड करेंगे, उतना ही तो है उसमें बात. ओके, सो ऑब्जर्व, see, quite same, everything is the same except for what we have here is the electrolytes. Okay, sorry, electrodes we have. Okay, which are the electrodes that we are speaking? The electrodes what we are speaking is over here. One is here and the another one is here, right? So these are the two electrodes. One is attached to positive charge and the another one is attached to a negative charge. Okay, now what will happen? Once we connect these things to our electricity, whatever the extra electrolytes we had, the extra electrolytes that we had in the soul, that is in the impure soul, that particular thing will migrate. Migrate यानी कि वो चला जाएगा अपने आप. You don't need to have a continuous flow of water. You can avoid excess use of water, because once you start this particular thing, once you start to give its electricity, what will happen is positive charges will go towards the negative terminal, and the negative charge particles will go towards the positive terminal of the electrode. Okay, now due to which all the ions will go away, and whatever the soul that you will get at the end, that is going to be as a pure soul. Quite simple. If you have understood the diffusion or dialysis method, electrodialysis method comes handy. Okay, so please do not forget to study these two particular methods, because these two methods are quite very important for your examination point of view, and you can expect it around. If they ask you about dialysis, 2 marks subdivision, and electrodialysis will be of 3 marks subdivision. Okay, quite simple as it is. Now looking forward with the next one. Anyone has any problem so far? Let me know. Have you understood it? If there is any problem with respect to any of these concepts? Let me know. Okay, I hope there is no problem. So let's start with the next one. Thank you, Adil. There is no problem. Fine. Okay. Properties of colloids. Now, properties of colloids. There are various properties of colloids depending upon their characters. Now, what are they? First one, optical character. ऑप्टिकल कैरेक्टर, उसमें एक पर्टिकुलर सेक्शन आ जाएगा टिंडाल इफेक्ट करके, जिसको हम देखेंगे बाद में। है काइनेटिक प्रॉपर्टीज। काइनेटिक प्रॉपर्टीज यानी कि किस तरह से वो पार्टिकल्स जो है वो मूव करेंगे, उसके अंदर हम पढ़ेंगे ब्राउनियन मूवमेंट को। नेक्स्ट वन इज इलेक्ट्रिकल प्रॉपर्टीज, अनदर वेरी इंपॉर्टेंट। इन दिस इलेक्ट्रिकल प्रॉपर्टी प्रूव्स that whatever the colloidal particles we have are having charges on them. Okay, that it will be proving by the help of electrophoresis method, जो कि और 3 मार्क सबडिविजन के लिए बहुत ही इंपॉर्टेंट है। कोलिगेटिव प्रॉपर्टीज वो सॉल्यूशंस में पढ़ जाएंगे हम। ओके, एंड द कलर्स। ओके, so right now for us important points what you can expect it in examinations are going to be 3. First one, optical property. Okay, that is a Tyndall effect, 3 mark subdivision question. Okay, and then comes is a kinetic property, 2 mark subdivision question for that is the Brownian movement. Electrophoresis, which comes in the electrical property, another 3 mark subdivision. Okay, so these 3 are the most important. Okay, so let us start with these one by one. Optical properties. Now, optical properties. Let us say that we have a homogeneous solution which is placed in the dark. Okay, अभी यहाँ पर मैं क्या consider कर रहा हूँ? Homogeneous solution. अभी homogeneous solution क्या हो जाएगा? First, let us say that we have a beaker and this beaker contains simple thing, a pure water. Let us say that it contains pure water. Okay, so it is going to contain pure water. In this case, if I add for this, if I add sugar, let us say I'm going to add sugar in this case. So if I add sugar and stir it well, what will happen? Sugar will get dissolved, correct? But can we see the sugar particles after, let's say, 5 minutes or 2 minutes? Can we see those? I don't think, right? So we cannot see those particles over here. But on the other hand, if I use, let's say, if I use over here a light source, यहाँ पर हम क्या यूज करेंगे? हम एक लाइट सोर्स को यूज करेंगे। ये लाइट सोर्स क्या करने वाला है? It is going to, of course, it is going to see that it is going to pass the light something like this. Now, once this light is going to come over here, can you see again any particles? If it is a homogeneous solution, I won't see anything. Okay, कुछ भी नहीं दिखाई देगा, एक clear सा solution दिखाई देगा बस, right? Because and if on the other hand, if I'm going to take into consideration of a colloidal system here, okay, if I'm going to take into consideration of a colloidal system, then क्या हो जाएगा? यहाँ पर जो particles रहेंगे, particles की size जो है, वो particles की size जरा सा बड़े रहेंगे when we compare to that of the true solution, correct? Because of which all these particles what we have, they will start to reflect. They will start actually to reflect whatever, they will start to reflect this light what is falling on them, and then they will start to shine. Okay, now this particular property wherein all these particular particles will start to shine once you observe this shining. Okay, once you observe this particular shining from the top, यहाँ से हम देखेंगे, जैसे कैसे देखने वाले हम, यहाँ से exactly 90 degrees को हम जब देखेंगे, तब हमको क्या लगेगा कि ये particular particles shine हो रहे हैं. Okay, so when we see any particular particles which is shining, which is scattering all the light which is falling on them, that particular thing is called as the Tyndall effect. Okay, this particular thing is called as the Tyndall effect. और ये जो कोन दिख रहा है आपको, ये जो कोन दिख रहा है ना यहाँ पे, okay, I will just select the range of the cone, and this cone, what we see right from here, okay, this cone is called as the Tyndall cone. Remember this, it's called as the Tyndall cone. Okay, so quite simple process. So what is a Tyndall effect? The Tyndall effect is nothing more than the path of beam of light which has been scattered or emulated by the colloidal particles. Why? Because the light which is falling on this particular soul particles, it is absorbing it and it is scattering those particular particles aside. Okay, because it is scattering all those particles aside, this particular effect is called as a Tyndall effect, and it is observed only in your colloidal solution. Okay, remember, it is observed only in your colloidal, it is observed in only in a colloidal solution. And the cone what is formed, we call it as a Tyndall cone. So let's observe the same particular phenomena with the help of a good diagram. Okay, so what do we have here? Observe. In the first case, what they have taken is a true solution. Okay, first one जब हम देखेंगे तो हमारे पास क्या है? यहाँ पर है true solution, right? This is the entire section of the true solution here. So if you see the true, whenever we pass any particular ray of light, it will just pass as if there is nothing in front of it. Okay, but when it is a colloidal solution, the colloidal solution will start appearing a little bit bluish in nature. And once we see that the particles are coming there, these particles will start scattering the light in all possible direction. Okay, it will start scattering the light in all possible direction, due to which it will start, like we feel that it is shining in nature. Thus, this particular particle, which is illuminating light in all possible direction, we call it as a Tyndall effect. And the cone what is formed over here, the cone what is formed here is called as a Tyndall cone. Okay, so another very important thing for your 3-mark subdivision. Coming forward with the next one is the kinetic properties. Now, kinetic properties, already you know what is meaning of a kinetic. Kinetic means the particular property of a moving body, right? Now, we are speaking about colloids. Colloids यानी कि क्या है? Particles है. Particles क्या रहेंगे? Continuous motion में रहेंगे. Okay. So, now, this random motion, the zigzag motion of the colloidal particles in the dispersion medium, we call it as a Brownian movement. Remember this, Brownian movement is most important. What is Brownian movement? It is nothing more than a zigzag, yani ki random motion of the colloidal particles. We call it as a Brownian movement. This is how it is represented. If you don't remember, just directly show this particular figure. It's more than enough. Okay. So at least you will get 1 mark over there, and just write down that is a Brownian movement. Okay, this is the most easiest question that you can get in the entire surface chemistry. What is Brownian movement? It's nothing more than a zigzag motion of the particles. We call it as the Brownian movement. Okay, so coming towards the next one, what we have is a electrical properties, and you should study this one. Okay, now electrical properties, यहाँ पर ऑब्जर्व करो, the stability of soles, we have already discussed this. Okay, जब हम ब्रेडिक साफ मेथड देख रहे थे, जब वो मेटल सोल प्रिपेयर कर रहे थे, तब हमने देख लिया था कि अगर इस पर्टिकुलर सोल को हम स्टेबलाइज करना चाहिए तो उसको कुछ स्टेबिलिटी या फिर स्टेबलाइजिंग एजेंट्स डालना चाहिए, राइट? So therefore the stability of the sole is due to the electrical charges. Electrolytes डाल दिए थे हमने सरफेस के ऊपर, like we had the different types of charges on the surface, right? So therefore the stability of the sole is mainly due to the electrical charges present on the colloidal particles. Positive soles, अगर positive soles यानी कि क्या हो जाएगा, जिस particular sole के ऊपर positive charge आ जाएगा उसको हम positive soles बोलेंगे, right? Okay, so metal hydroxides such as a hemoglobin, metal hydroxides such as a ferric chloride, aluminum hydroxide, chromium hydroxide, soles such as hemoglobin, basic dyes. are called as positive soles. You don't have to remember this. Okay. Negative soles, metallic soles such as copper, okay, silver, gold, which are obtained by Braddock's arc method. Already we had seen that. Okay, so such kind of soles actually require charge on their surface in order to become stable. Okay, so now, okay, coming towards in a sole, colloidal particles are generally aggregates of a large number of particles, because of which the dispersed phase particles in a sole is comparatively small when compared to the true solution. See the number, यानी कि क्या हो रहा है यहाँ पर colligative property में, जब हम एक colloidal particle या फिर colloidal solution form करते हैं, that time what will happen is all the particles will start coming close to each other, due to which they will form a big particle, but the number of particle is reducing, but the size of the particle is going to become more. Okay, due to which it has a direct effect on its colligative properties. Now what is a colligative property? You have already seen in the chapter solution. Okay, so in a solution, the number of these particles will be less, but the size is big. The only thing is size will become big, but the number of particles will go down. Okay, because all of them are coming close together and they are forming some big molecules. Hence, colligative property is less than those of the true solutions of the same concentration. Okay, now before going further, that is going to be the color. Okay, so depending upon the size of the particle, what you'll have is the different color. Now if you observe 6 nanometer, if you have a 6 nanometer particle size, colloidal particle size, then that colloid will show you yellow color. If it is 9 mm, okay, so a little bit smaller than this, छोटे होते जा रहे हैं. सोचो यहाँ पर 6 नैनोमीटर है, 9 नैनोमीटर, नैनोमीटर्स में चले जा रहे हैं. Okay, so after that what will happen? 9 nanometers, 13 nanometers, 15 nanometers. So what is happening? 9 nanometers red, 13 nanometers purple, and 15 nanometers violet. Okay, so coagulation of coagulation or precipitation of soles हम कल देख लेंगे. Okay, so right now we had to complete with one more thing in electrical properties, and that is called as electrophoresis. Okay, so electrophoresis. First thing, you need to understand that in electrophoresis, what they do is they are going to see that they will be having one apparatus which is called as a U-tube. Now, U-tube, in a sense, it is going to be a U-shaped tube, something like this. This is a U-tube. Okay, so in a U-tube, what they do is they insert metallic rods like this. Okay, so after inserting the metallic rods, what they do is they'll pack this thing with a solution or a colloidal solution. Okay, they are going to pack this thing with a colloidal solution here. So what we'll say is we are going to see that this entire thing is going to contain now colloidal particles. So this is going to be all the colloidal particles here in the solution, right? So they are going to take this and they are going to fill this one with the solution of electrolytes. Okay, so after doing that, they'll pack this one and then they are going to see that this one electrolyte or one particular metal particle, one particular metal electrode is going to be connected to the positive terminal, and the one which is negative one is going to be connected to the negative terminal here. Now, after doing that, what will happen is once it is connected to the batteries, now these particles, if you see these particles what we have here, okay, these particles will start moving towards one of the terminal. क्या हो जाएंगे यहाँ पे? It will start moving towards one of the terminal. अगर अगर इस particles के ऊपर charges जो है, अगर इस particles के ऊपर charges जो है, अगर वो negative रहा, then what will happen is all these particles will start moving towards the positive terminal. On the other hand, if the particles are going to have the negative charges over them, then all these particles will start moving towards, sorry, if they have the particles, if they have a positive charge on them, then they will start to move towards the negative charge. Okay, so this particular process, what we have, this particular process is called as the process of electrophoresis. Okay, remember this, it's called as the electrophoresis. Now, if anyone has any other doubt, please let me know. Have you understood all the concepts for today? Or if there is any other doubt, please, you are free to ask the questions now. You can type down the question in the chat box and just let me know if you have any other problem. Okay, Uzma says no doubt. Okay, thank you. Anyone has any other doubt? Okay, Afreen says no doubt. Okay, Adil, no. Okay, Uzma. Okay, Uzma, I'm sure that you will get the notes today. Okay, by today afternoon, I will see that the notes will be dispatched by Patil sir to you. Okay, to your personalized email IDs at least you will give, or you will send it on the group. So don't worry about the notes today. You will get those. Okay. So anyone else? Okay, fine then. So let's end the meeting for today. Okay, take care. Bye.